Welcome to This Explainer. Today, we're cutting straight through the relentless AI hype and taking a hard, investigative look into the gritty reality of open source development. We hear constantly about artificial intelligence transforming the world, but how are these incredibly complex systems actually built, maintained, and, how do they break? Well, we're going to explore the very first large-scale empirical study of open-source multi-agent AI systems to find out exactly what's going on under the hood. Here is our roadmap for today. 1. The AI agent boom. 2. How AI is actually built. 3. Features over fixes. 4. What breaks AI systems. And 5. Momentum versus fragility. Let's dive right in. Section 1. The AI agent boom, beyond the hype. Okay, before we jump into the data, let's make sure we're all on the exact same page. We aren't just talking about your standard single chatbot here. We're talking about multi-agent AI systems, or MAS. These are complex architectures where multiple specialized, completely autonomous agents actually collaborate, communicate, and coordinate to solve really complex workflows. Think of it like a digital corporation. You've got different AI workers with distinct roles, from planning to memory retrieval to actual execution. And to really understand this space, researchers analyzed an absolutely massive data set, 42,267 unique code commits. That is the incredible scale and empirical weight of the study we're unpacking today. We're looking at the literal digital footprints of the developers who are building our AI future. So let's meet the main characters of our story. These are 8 of the absolute leading open source frameworks powering the multi-agent boom. Notice those GitHub stars? These projects are massively popular. You've got LangChain leading the pack with its modular chain architecture, AutoGen with conversational workflows, all the way down to Super AGI. What's really fascinating here is the wildly diverse ways they try to solve the same problem. Whether that's CrewAI's role-based hierarchy, kind of mimicking human organizations, or Llama Index's heavily data-centric pipeline.
Notice the sheer disparity in development intensity here. That massive gray bar for LangChain, over 14,000 commits. It completely, absolutely dominates the development volume. But, don't ignore the black bars. Those represent reported issues. Semantic Kernel and Haystack have a remarkably high volume of issues compared to their commits, which tells us they have huge active developer communities actively wrestling with the technology.
Section 2. How AI is actually built. A tale of 3 profiles. By digging into all those thousands of commits, the study revealed that, not all AI is built the same way. The ecosystem essentially breaks down into a tale of 3 profiles. First up, you have the marathoners, showing sustained development, like LangChain, with continuous, highly elevated activity. Then you have the reliable walkers, showing steady development, like Haystack, exhibiting consistent, predictable growth. And finally, you have the sprinters showing burst-driven development, like Super AGI, which is characterized by incredibly intense but short-lived spikes of coding. If we look at the coefficient of variation in monthly commits, a higher number just means a more irregular pattern. Notice that pink bar right at the top for Super AGI, clocking in at 456.1. It is a wildly burst-driven project. Now, look all the way down at the bottom. Haystack sits at a super calm 48.6, demonstrating a remarkably steady, reliable consistency over time. This brings up a really vital question about the nature of open source AI development right now. With so much immense pressure to innovate constantly, what actually happens when developers prioritize shiny new capabilities over fundamental stability? Let's take a look. Section 3. Features over fixes. The cost of momentum. All right, the absolute crux of the issue is found right here in the types of code developers are writing. Researchers used a machine learning model to classify over 42,000 commits. Nearly 41% of all commits are what they call perfective, meaning they are solely focused on enhancing features and making things shinier. It's literally like prioritizing a custom paint job on a car before even checking if the engine works. That significantly outpaces corrective commits, which are your basic bug fixes, sitting at 27.4%, and adaptive commits, which adjust the system to new requirements, at 24.3%. What this essentially screams out to us is that feature development is dramatically outpacing reactive bug fixing. The AI ecosystem is in an aggressively proactive growth phase. Developers are literally racing to build the next cutting-edge tool or integration before they've even fully stabilized the tools they built last month. It's an ecosystem sprinting forward, heavily biased toward continuous improvement over foundational maintenance. And as you'd expect, this leads to some intense code churn. Notice the bottom chart for LangChain. Those green spikes? Those are lines of code added. But look at the massive red spikes in 2024 and 2025. Those are huge deletion events. In one case, nearly 400,000 lines of code were just removed. That is some serious Marie Kondo-style code cleanup, just to maintain their architecture.
Section 4. What breaks AI systems? The friction under the hood.
So, with developers overwhelmingly focused on pushing out new, perfective capabilities every single day, we really have to ask, what does it look like out in the wild when these intricate, multi-agent orchestrations fail? The reality might actually surprise you. You'd probably expect futuristic, sci-fi coordination issues to be what breaks these systems, right? But the data? Basic software bugs account for 22% of all issues. Infrastructure problems, things like deployment pipelines and Docker containers failing, make up 14%. Actual agent issues only account for 10% of reported problems. The friction isn't just in the AI itself, it's in the basic software engineering. To put that into perspective, technical implementation issues entirely dominate the developer's day. Meanwhile, user experience concerns, like CLI interfaces or basic developer tooling, make up a mere 2% of reported issues. Developers aren't currently wrestling with surface-level usability. They are down in the trenches, fighting with deep operational barriers just to get these agents to run properly. And fixing these deep operational barriers, it really takes a toll. Take a look at these box plots showing issue resolution times. The horizontal line in the middle of each box is the median resolution time, which often looks totally fine, sometimes just a couple of days. But look at that purple X in each box. That represents the mean, or average. In every single framework, the mean is significantly higher than the median, dragging out into weeks. This exposes a massive imbalance. While easy bugs are squashed fast, a large subset of critical issues are incredibly stubborn and take weeks to resolve.
Section 5. Momentum versus fragility, the verdict.
This chart tracks the cumulative growth of issues, and honestly, it is a perfect visualization of the ecosystem's struggle. Notice how almost every single line flatlines until exactly 2023, and then suddenly skyrockets upward. Issue reporting absolutely exploded right alongside development. It reflects a developer community that is fighting really hard to keep pace with the massive, complex systems they're creating. The researchers actually did a topic analysis on these issues and found the core tension defining AI right now. Almost 58% of developer attention is actively focused on pushing the boundaries of agent systems and intelligence, things like planning, memory, and multi-agent chat. Yet a massive 33% of their time remains locked in a frustrating battle with basic technical and operational deployment barriers. To sum it all up, the researchers' definitive conclusion serves as a pretty stark warning. These results highlight both the momentum and the fragility of the current ecosystem, emphasizing the need for improved testing infrastructure, documentation quality, and maintenance practices to ensure long-term reliability and sustainability. We are literally watching a technological revolution being built in real time. But based on all the data we've explored today, I want to leave you with this thought. Are the AI systems we are beginning to rely on building a robust future, or are they simply racing ahead of their own fragile infrastructure? Think about that as you continue to watch this exciting space evolve. Thank you so much for joining me on this explainer, and keep learning.